Alright, I'm going to start a new series of videos. I made a video of this little motorized bike that I built. It's an eBay kit, little 66cc two-stroke. And I got a few other little parts for it. I got the homemade chain tensioner, the new hub adapter and sprocket assembly, and a few other little performance parts I made. But I'm going to go and make a bigger change, and I'm going to swap to this 4-stroke 99cc engine. It's equivalent to a 3 horsepower. Got it at Harbor Freight, and we'll see how it goes. I'll just get a little zoom in on here. You see horizontal shaft engine. Also got the centrifugal clutch, and on these engines it's a 5/8 inch diameter shaft. But there's a little problem with that, and I read this on the website, on the reviews of this engine on the Harbor Freight website, and turns out to be completely 100% true. So I got my little dial caliper here. I'll turn it on. And what the problem is this engine shaft is bigger than 5/8. So keep in mind, decimally 5/8 is 0.625 inches, and that shaft measures out to 0.636. So that's a problem. And I got the clutch here. And the clutch measures out, the inside diameter of the clutch measures out to a perfect 5/8 of an inch, 0.625. So basically what we got to do is reduce the diameter of this shaft, and I'll show you how I'm going to do that. Alright, now here's what I'm going to do on this engine to get this shaft reduced in size. Obviously, to take this to a machine shop would defeat the whole purpose. This is a, like I said, it's a Harbor Freight engine. I think I paid $90 plus tax for it. So to disassemble it, take it to a machine shop, have the crankshaft turned down, would absolutely defeat the purpose of buying a cheap Harbor Freight engine. You'd be better off to go and buy a Tecumseh or a Briggs & Stratton or a Honda that has a perfect 5/8 inch shaft. So what I'm going to do is I'm going to fill it up with oil, fill it up with gas. I'll get it mounted to, I got a piece of 3/4 inch plywood, and I'll get it mounted on some sawhorses. And basically what I'm going to do is I'm going to run the engine. And I've got this sandpaper here. This is 80 grit, and I've also got some 180 and some 240. Basically what I'm going to do is, while the engine's running, I'm going to let this sandpaper ride on the shaft and get this shaft reduced down to the size I need to fit my clutch. So I'll get started on that. I'll get a piece of plywood and get it mounted up, fill it with oil, put a little bit of gasoline in it, and get it going. I'll show you something else here that's kind of, the factory throttle setting can kind of sit in one position. It's not a spring fit, at least not yet. I gotta hook it up to to the existing hand throttle. But I'll just set this at about a medium speed, let it run, and like I said, use this sandpaper under the shaft just while it's running, and just take measurements every now and then, and make sure I don't go too small. This is supposed to be a little bit of a press fit. There is a hole in the middle for the bolt. I believe it's a 5/16 fine thread. So the bolt is what really holds this on. But you do want this to be a little bit tight. So I'll get going on that. I'll get it mounted to some plywood, filled up, and shoot some more videos. So there's the bottom side of the engine, and you can see the 4 little mounting holes. One there, 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 and there. it also comes with this little bracket here. Pan down here. So this bracket is perfect. These inside holes mount to the engine, and these outside holes can mount to whatever you're putting this on. You can also just mount the engine just flat. It is flat across here. There's no obstructions across the bottom, so this can be mounted flat, just on the base of the engine. But I'm going to use this little bracket, and it's perfect because now I got a template to mark and drill my holes. So I'll get going on that and keep filming. Okay, as you can see here, I do have my holes drilled into my piece of plywood. These bolts right here, they come with the engine. They go here in these holes. They mount this bracket to the engine, or if you got a flat piece of steel or whatever you're mounting this on, they go into the engine. Real simple. Then I also got over here some 5/16 bolts, a few washers, and some nuts. What I could find in my box of bolts was nylock nuts. So we'll get started putting this all together. Real quick point of reference, the head of these bolts, take a 10mm socket or wrench, however you want to do it. But the head of the bolt does take a 10mm. And then of course, the 5/16 that I'm using uses 1/2" socket and wrench. So, but these here, again, 10mm hex head on there. All right, now you can see the engine mounted to this piece of plywood, and it's real basic. You just get your bolts in there. I really can't get down to the bottom ones, but you get the picture. Nothing to it, and just tighten those down, and then we'll get it set up and ready to run. And here it is. I got it clamped down. I got a more stable table. That little metal table is real flimsy, so I got a more stable little work stand, and I got the engine bolted to the plywood, and got the plywood clamped down to the bench. And now all I got to do is come in and fill it up with oil, fill it up with gas, and see if it'll run. So keep watching, and we'll see if we can get this thing started. Alright, so I got the gas filled up. I put about a pint, maybe even less than that, of gasoline, because I'm probably going to have to take this tank off. There's definitely going to be some welding required to make an engine base plate on that bike. So I don't want to have too much gasoline in there, because I'm just going to have to take the tank off when I do the welding. And so anyway, I'm putting oil in it. I'm just running some regular old cheapy 10W30. That's what the manual states. And I'll get in here on the oil level. And so we'll get it, it's not quite full, but I'll keep filling it up. And then we'll try and start this.